थोड़ा अभी थोड़ा इम्पोर्टेंट है बेसिक्स टाइम पास हो गया हाँ सर गुड मॉर्निंग स्टूडेंट्स myself Shekhar Gouda. So I am your chemistry teacher. So today we will start our first topic, structure of atom. This is our first topic in chemistry. Right, before starting topic, let me introduce. So what is the importance of chemistry in PU1 and PU2, and what are the main important topics included to crack JE or NEET, okay, any kind of medical or engineering examination. Right, if you see the NCERT syllabus in PU1 means 11th standard, so we will be having topics like structure of atom. Next, there are three categorized means chemistry. You can, for our understanding, you can divide it into three parts mainly. One is physical area, second one is organic area, third one is inorganic area. So this structure of atom comes under physical chemistry topic. Physical means, so there are what natural means, or most of the it will be like little physics, okay. So in this topics we will do many numericals, and there are many principles like in physics, and it will be interesting once you know the concepts, okay. So if you get the concept, then so like physics you can do the applications. So and mainly in physical chemistry, so we will be having most of the numerical areas. So in this physical chemistry topic, so we have some connections with physics, okay. So if you are good in physical chemistry topic, definitely you will enjoy physics also, or if you are interested in physics, definitely you will feel more comfort in physical chemistry area. Right, now let me introduce topics in chemistry, okay. So you have 2 years of program to crack NEET or JEE, whether advanced or JEE mains or any engineering examination. So you need to study 11th and 12th. So there are 2 years. In 11th year in chemistry, we will be having physical, organic, inorganic, 3 main areas. Same in second year, means in PU2 also you will be having physical, inorganic and organic. In physical chemistry area, so there are topics. This is what the first topic, structure of atom, is main one basic and important topic. After that, some basic concepts in chemistry also. That is what one important basic topic which will connect with all other physical chemistry and inorganic and organic topics. Here structure of atom and some basic concepts in chemistry. Later gaseous state, that means states of matter, and thermodynamics and equilibrium, chemical equilibrium and ionic equilibrium, and so mainly these are the 5 topics. One is structure of atom, second one is some basic concepts in chemistry, third one is states of matter, and fourth one is thermodynamics, and fifth one is equilibrium. Equilibrium divided into 2 parts, chemical equilibrium and ionic equilibrium. So these are the physical chemistry area topics. Next, if you see the inorganic area topics, inorganic classification of elements and periodic table, first topic, and second one is chemical bonding, second topic, and third one, so you have group wise S block elements and P block elements. In the S block elements, alkali and alkaline earth metals, and P block elements, in 11th we have 13th group boron family and 14th group carbon family, and apart from this S and P we have hydrogen and its compounds. So we will discuss separately about hydrogen and its compounds. So these are the main important topics in inorganic area. Then if you see the organic area, in organic area, first basic things like classification of organic compounds and their naming, nomenclature of organic compounds, and stereochemistry. After stereochemistry, then general organic chemistry. So based on the general organic chemistry, we have to explain the stability of different kind of organic products, reactants and intermediates. You can explain the stability, and after doing this electronic displacements, basic GOC general organic chemistry topics, You can explain SD character, basic characters, and stability of intermediates. Which one in the reaction, which one is the major and which one is the minor. So these are the main important things you can explain. After that, so types of organic reactions. So these are what general organic chemistry. Next, after general organic chemistry, we have topics like alkanes means hydrocarbons. Hydrocarbons are what? Alkanes, alkenes, alkynes, and benzene, its compounds. So these are the topics included in the organic PU1 syllabus. So these are what we are going to discuss now. Today we will start the structure of atom. This is our topic in physical chemistry area. Right, now you know what is atom? Right, what is the structure of atom? Right, so here to understand chemistry, atom is very important. You know that what is atom? How you will define the atom? So atom exists everywhere in the universe. So in any kind of matter have atoms. So atoms are the smallest or teeny or building blocks of matter. So if you see the any kind of matter, either solid or liquid or gas, if you take any kind of matter, in every matter there will be a smallest particle. That name is said to be atom. So atom is the smallest particle in the matter. So either gaseous or liquid or solid. This already you know that what basic idea. Right. Now in this topic mainly what we are going to discuss, what is the atom and how scientists discovered the atoms, and in the atom what are the subatomic particles present like electron and proton and neutron, and in the atom there are mainly two parts. One is nucleus and rest of the nucleus, and how will be the nucleus, and in the nucleus what are the particles are present, and how electrons will be existing in the atom. So this is what we are going to discuss. This is what structure of atom. Structure of atom means once you know the atom, so after knowing the atom, so in the atom what are the other subatomic particles, and these particles how they will be arranged in the atom, and how these atoms are getting stability. This is what we are going to discuss in this topic. This is what main importance of topic. So what is atom and how scientists discover the atoms, and in the atom what are the particles, other subatomic particles like electron and proton and neutron. After knowing electron, proton and neutron, then how these scientists were discovered electron, proton, neutron in the atom, and what are the experiments and how they did experiment. These are all we are going to discuss in this topic. After finding electron, proton, neutron, and how these particles will be arranged in the atom, and by that how atoms are getting stability. This is what we are going to discuss. Next one thing here, in previous classes, in the basic especially, we have atomic mass, atomic number, okay, and these are the main important two terms. These two terms we will discuss in this topic also in very detail. After knowing the atomic number, you will get what number of electrons. After knowing the number of electrons, how these electrons will be arranged in the atom. How these electrons will be arranged in the atom. This is what mainly we will discuss. In the structure of atom, there is no importance of neutron and protons in this topic. Okay. So mainly in this topic, how electrons will be arranged in the atom. This is what we are going to mainly in this topic. Right. Right. Now let me start the topic. Tell me here, what is atom? Right. Before knowing structure, how scientists were discovered atoms. Definitely in the matter there will be one smallest particle. So this idea given in many our traditional books and mythological books and in our philosophical books. So there are many things. Even our Hindu culture also, in Bhagavad Gita and in Vedas also, we will be having about atoms. In every matter there will be one smallest particle. Its name is what? Atom in English. If you talk in Kannada, that is what? Paramanu. Atom is what? Paramanu. Even in Hindi also, Paramanu. Paramanu means it's a god. Okay? So Paramatma is the god. Means everywhere atoms are present in the matter. So that means what? God also present everywhere in the matter. This is what we have basic idea in our philosophical books like Greek and Hindu and Chinese. So whatever books you take it in before Christ. So there are many books gave this idea. In every matter there will be one smallest particle, that is said to be atom. So atoms are the smallest particle. This is what we have theoretical idea from the books. Next, after 18th century, one man, his name is John Dalton. Okay, John Dalton. So Dalton is the he was the first man. He gave one theory to know the structure of atoms. So John Dalton, he was a one British teacher, school teacher. Okay, and he proposed one theory on atoms. Now let me give what are the postulates of atomic theory according to John Dalton, and what are the postulates he gave without doing experiments. At the time of 18th century, there are no experimental evidences. Without experiments, without doing any experiment, just he thought and he gave some postulates. Most of the postulates right now they are supporting with the experimental evidences. That means he is the first man. He predicted and he thought according to his thoughts. Most of the points, most of the postulates are matching with the current experimental data. So that is what the advantage of John Dalton atomic theory. Right now we are going to discuss Dalton's theory. Dalton's atomic theory. First theory, Dalton's atomic theory. Okay, Dalton's theory. What is the Dalton's theory? This is the first theory to know the structure of atoms. To know the structure of atoms. Right. According to this theory, first postulate was in the matter smallest particle is said to be atom. In every matter, whether it is solid or liquid or gas, whatever, smallest particle in the matter is said to be smallest particle in the matter is said to be atom. This was the first point given by the John Dalton. In every matter there will be one smallest particle. Its name is what? Atom. Right. Next, all matters are made up of with what? Atoms. So atom is nothing but what? Building block of matter. You can say that atoms are what? Nothing but building blocks of matter. So by repeating what n number of atoms, you will get what? Matter. Matter means what? Here compound. Here different kind of compounds. Different kinds of compounds. In every compound, there are smallest particles. Those are said to be atoms. Now atoms are the very smallest tiny particles which are building blocks of matter. This is what the first point given by John Dalton. Without doing experiments, just he gave this point. Still, this is what we are accepting. Atom is the smallest particle. So in the atom there are other subatomic particles like electron, proton, neutron. Okay, right. Now this is what smallest particle. Next, second postulate. So atoms are what? There are a number of atoms. Means atoms are repeating particles. Atoms are repeating particles in the element. Atoms are repeating particles in element. Element is made up of n number of atoms. So in element there are n number of atoms. So here don't confuse here. What is the difference between element and atom? So element is what? Like a carbon element, like iron element. So in iron element, so that is what one kind of matter. Iron is the what? Solid matter. So that is what we are calling iron element. So in that iron element, there are repeating iron atoms. So repeating iron atoms, we will get iron element. That is what building block of iron atoms, we will get iron element. Okay, element is the what? One entity which is made up of repeating unit of atoms. Like carbon, iron, silver, sodium. Like that, there are many elements. This is what relevantly second postulate also, like first postulate only. Right. Next point is atom. So according to Greek and Latin, atom is what? Greek and Latin. Greek and Latin. Atomium is, what is atomium? Atomium means uncuttable, or undivisible. Uncuttable or undivisible particle. According to Greek and Latin, atom means, this actually atom word, whatever the atom word we are using, this is what Greek and Latin. According to Greek and Latin, atomium means uncuttable, means you can't cut further. That whatever the element, if you take it, then go on cutting, definitely you get one smallest particle. After getting the smallest particle, so you can't get further, you can't cut the further smallest particle. That whatever the smallest particle is to be atom. Undivisible means you can't do the undivisible, means you can't do the further division of smallest particle is said to be atom. That is what Greek and Latin. That is what Greek and Latin word. Atom is the Greek and Latin word. Next, John Dalton. So this is what the John Dalton made. First postulate is what? Repeating units are present in the element, and element is nothing but what? It's a kind of matter. In any kind of matter, there are atoms. Atoms are the building blocks of matter. So here matter will form the compound. Next here, chemical reaction. How we explain here chemical reaction? Chemical reaction. According to John Dalton, what is the meaning of chemical reaction? So what is the meaning of chemical reaction? Here, according to John Dalton, chemical reaction is, from the chemical reaction only we are getting different kind of compounds. How we are getting different kind of compound means rearrangement of atoms. Atoms will give what? Compounds. Will give compound. So this getting compound is said to be chemical reaction. So earlier what, according to Dalton, O and O. Okay, this is what oxygen. O and O means right now we have double bond. Earlier you don't have the what, double bond, and there is no concept of bonding. Now this is hydrogen and this is what oxygen. Here two hydrogens combined with one oxygen. This is what one oxygen atom. You can take it here one oxygen atom. Then what you are getting here? There will be a rearrangement. Now this is what hydrogen here. This is the oxygen atom. Now this oxygen atom. On this oxygen atom, there will be arrangement of two hydrogen atoms. This resulted means here the rearrangement. Here and here this is what oxygen atom. This is what oxygen. This is what hydrogen atoms. When hydrogen atoms, two hydrogen atoms rearranging on the oxygen, by that you are getting the water. Just rearrangement of atoms, one with the other one, resulted we are getting what? Compound. That name is what? Here what we are getting. This is what he explained. Okay. So chemical reaction also will be explained. Due to what rearrangement of atoms only we are getting compound. This is said to be chemical reaction. Next, when any atoms, when they undergo chemical reaction, definitely they need to satisfy some laws, and these laws later in some basic concepts in chemistry. Right, what are the laws? This Dalton's law is what explaining about law of constant proportions, and law of conservation of mass, conservation of mass, and law of multiple proportions, and law of multiple proportions. This Dalton's law successfully explains law of constant proportions and law of conservation of mass and law of multiple proportions. We have two hydrogens and one oxygen. That means every compound has its own constant proportion of elements. Yes or no? This is what law of constant proportions. If I have the carbon dioxide means one carbon, two oxygens. This is what constant. One carbon with two oxygen. Name is what? Carbon dioxide only. Irrespective of source. From where we are getting doesn't matter. Carbon dioxide means one carbon, two oxygens. This is what law of constant proportion. Water means one oxygen, two hydrogen. Then formula will be H2O. Next, if you take it ammonium, ammonium is what? NH3, one nitrogen, three hydrogen is said to be what? Ammonia. So for a compound, then this elemental proportion will be constant. That is what law of constant proportions. In every compound, there will be a constant proportion of elements. That is what law of irrespective of source. From wherever you take it, formation of water. Water means two hydrogen, one oxygen. That's it. Whether you prepared water in the Earth atmosphere or on moon planet. So on any planet, water means water only. Water means water only. That is what constant proportion. This is what the law should satisfy when there will be chemical reaction. Now according to Dalton also it is matching. Next, law of conservation of mass. Like what is the law of conservation of mass? Before the reaction and after the reaction. So some of the masses must be same. For example, here 2 hydrogen and 1 oxygen. 2 hydrogen mass will be what here 1 gram plus 1 gram. And here 1 oxygen 16. So here totally 2 grams. So 2 grams of hydrogen combined with 16 grams. Then what you have to get here? If I ask what is the molar mass of water, it will be equal to 18 grams. Before the reaction, whatever the mass we are adding, same amount of mass we are getting in the product. That means you cannot create and destroy the mass. Means you cannot create and destroy the atoms. According to John Dalton, we cannot create and we cannot destroy the atoms. They will exist in the nature. Just what you can do it, just you can transform one arrangement to other arrangement. This is what arrangement in the reactant and this is what arrangement in the product. By doing arrangement, when we are doing arrangement to get compound, in that, so before whatever mass you have taken, same mass will be in the products, will be in the product. Here before 2 grams plus 6 grams you have taken the reactant. By combining these two, you have to get 18 only. That means what before and after reaction, mass must be same. That is what law of conservation of mass. You can't create and you can't mass. Whatever the mass or how much mass you have taken before the reaction, same mass you have to get it. This is what law of conservation of mass. This also satisfied. Next, law of multiple proportions. What is the law of multiple proportions? For example, let me give it a law of multiple proportions. For example, H2 plus O2 is there. What is it over here? If I have half O2, then I get water. If I have H2 plus O2, then what I get here? I will get H2O2. So what is the law of multiple proportions? Multiple proportion means you need to keep one of element as constant. Here we are keeping H2 as constant. What we are changing here? I am changing only oxygen. Here I am having water. Half O2 means one oxygen atom. By that I got water molecule. If I take 2 oxygen atoms, means O2 molecule. Then by that I got hydrogen peroxide. Okay, right. Once if I change one of element, you have to keep it constant. By changing other element, definitely you will get the multiple products. This is what law of multiple products. This is law of multiple proportions. Law of multiple proportions. Next, this is what one example you can take it. Next, second example, carbon plus oxygen. What you get from half oxygen means carbon monoxide will get. This is sulfur dioxide and this one is sulfur trioxide. Here in first case, H2 react with oxygen. Water, H2 react with oxygen, H2O2. Now here, let me ask one question. So what is the product when there will be reaction between hydrogen and oxygen? Then what you have to give answer? OH is not a stable product. It's intermediate. OH minus we get. That is ionic. Now my question is here, H2 react with O2. Let us see. Now what if I add here 2 gram of H2. This is what 2 gram H2 and 16 grams of O2. By that I get water. Now here 2 grams of H2 and here 32 grams. Then I get hydrogen peroxide. This is what hydrogen peroxide. This is a hydrogen peroxide. These two are what? Hydrates of oxygen. These two are what? Hydrates of oxygen. Right. Whenever I am asking question like hydrogen and oxygen, when they react, then what are the resultant product? What is the resultant product? Means what you have to ask, sir, what proportion you are mixing? That what you have to ask him. Right, taking what weight ratio 1:8 is the simple ratio, no? Yes or no? Simple ratio 2 ones are 2 8s are. If I mix hydrogen and oxygen with 1:8 weight ratio, then product is water. Product is water. If I add here 2 ones are 2 16s are. Yes or no? If I mix 1:16 ratio weight ratio of H2 and O2, then what is your product? hydrogen product, hydrogen peroxide will get. Hydrogen peroxide, 1 is to 10, carbon is what 12 grams, and oxygen is here what 16 grams. 12 and 16 ratio, you will get carbon monoxide. Here 12 and 32 ratio, in that we will discuss. Right, this law successfully explained by the John Dalton atomic theory. Right, these are what the merits. Okay, these are the merits of John Dalton. Right, now what are the demerits? What are the demerits? At the time of John Dalton, there are no experimental evidence. So just theoretically points, drawbacks. Here first note point is what? No idea about molecule. No idea about molecule. He did not explain about molecule, just atoms and compounds. Just he gave the what rearrangement of atoms, we are getting compound. Compound like water, compound like carbon dioxide, like the different compounds we are having. Means we are getting, there is no idea of molecular idea. So proposed later, not at the time of John Dalton. This is what no idea about molecule at the time of John Dalton. Next, second one, there is no idea about isotopes. At the time of John Dalton, we know the hydrogen atom, but not isotopes of hydrogen. We know the carbon, but not isotopes of the carbon. So no idea about isotopes. It is right now, atom further divided into other subatomic particles, smallest particles like electron, proton, neutron. So that what according to John Dalton, no idea about subatomic particle. So these are the drawbacks. Right now, from the latest atomic theory, we will get what idea of molecule, and we will get what idea of isotope, and we will get idea about what the subatomic particles like electron, proton, and neutron. So these are the things we are going to discuss with experimental evidence. How scientists were discovered electron, and what are the experimental evidence, and proton how they discovered, and neutron also how they discovered. These are, and after discovery of subatomic particles, how they will be arranged in the atom to get stability of atom. So where what is electron, and where it will be present in the atom, and what is a proton, and where it will present, what is a neutron, and where it will present in the atom. So this is what experimentally, so one by one, step by step, we will discuss discovery of subatomic particles. Okay, right now this is what idea of John Dalton. John Dalton is the first theory. Okay, John Dalton theory is the first theory. According to John Dalton, smallest particle or building block of matter is said to be atom. According to Greek and Latin, so atom is what smallest which is uncuttable. Atom means uncuttable or indivisible particle is said to be atom. That is what the smallest. So same way here, according to John Dalton also, smallest particle which is the what making complete matter is said to be atom. So then in the compound you will be having smallest particle, that also atom. Next, this John Dalton theory means atomic theory successfully explained chemical reaction. What is the chemical reaction according to John Dalton? Rearrangement of atoms is said to be what? Chemical reaction. From the chemical reaction you will get compound. Let me give the example. Here hydrogen, these are the hydrogen atoms, they are rearranging. On the earlier we will be having only hydrogen atoms. Here one side we have separate oxygen atoms. Now these hydrogen atoms are arranging around oxygen. Two hydrogen are arranging on the one oxygen. Resultant you are getting water. This is what said to be chemical reaction. So now whenever there is a chemical reaction, definitely it has to follow some laws. These laws are said to be law of chemical combinations. What are the law of chemical combinations? Law of constant proportions, law of conservation of mass, and law of multiple proportions. All these laws will be successfully explained from the Dalton's law. So these are the what law of multiple proportions. Next, what are the main drawbacks of John Dalton? These are the merits of John Dalton. Next, what are the drawbacks? Drawbacks means what? There was no idea about what molecule. He did not give idea about molecule, and no idea about isotopes. We have what different kind of isotopes like hydrogen, deuterium, tritium. This there is no idea. And next, no idea about what atomic particles, subatomic particles like electron, proton, and neutron. So this is what idea. Okay, no idea about this with respect to current situation. Currently we have what molecular concept, currently we have isotopic concept, currently we have electron, proton, neutron concept. But at the time of John Dalton, so in the 18th century, no idea about this. These are what drawbacks, and these are what merits. He successfully explained chemical reaction and these laws, and atoms are the what simplest particle and rearrangement of atoms in the chemical reaction. This is very important. Mostly this one, rearrangement of atoms is said to be chemical reaction. Is very important. Okay, it successfully explained this point. Okay, right. These are the main important points. Next, this was general idea already you know that. Next, discovery of subatomic particles like electrons, protons, and neutrons. So our next topic is discovery of electrons and protons and neutrons, that is subatomic particles. How scientists were discovered different subatomic particles which are present in the atom. It means with experiments. How they explain and how they proved experimentally there are electrons, protons and neutrons. How they will be arranged inside the atom. So that is what we will discuss right in the next class. So I will take from tomorrow onwards we will start main important topic to discover subatomic particles. Okay, right students. So please read NCERT. Hereafter you have to read NCERT textbook or any Karnataka state book also as it is NCERT. So you can read NCERT or Karnataka state book. Anyone you can take it, but you need to read NCERT content. So every day please read NCERT and make please one shortcut notes. Okay, you have to make one running notes and read NCERT and together so you can make clarity on the concept. So then so you can practice the numericals. Okay, right. So tomorrow session we will start discovery of subatomic particles like electron, proton and neutron. This one. Okay. So thank you.